Today, lesson 22A, day number 2 of rational number operations. So we just sort of extend off of our discussion yesterday, and our discussion yesterday was solely on finding the sum or difference of rational numbers. We defined what a rational number is, and typically in 6th grade it's defined to be any number in the form of a fraction, or that can be written as a fraction. We gave the official definition yesterday as any number that can be written in the form a over b, where a is not equal to 0, or excuse me, b cannot be equal to 0. And we restricted everything yesterday to two numbers. And once again, this was the official definition of a rational number that I gave you yesterday. All of these are rational numbers because we can write them in the form a over b, where b is not equal to 0. We talked about the fact that in order to add or subtract things, we need like units or same units and fractions. That means we need to have a common denominator. With decimals, we need to make sure that we line up the appropriate units. So ones need to be lined up, tenths, hundredths, and so on. And so yesterday we did problems like this, so I would like all of you to find either the sum or the difference for all 5 of those. We will compare with our shoulder partner. Notice, as usual, lately we have a specific sentence frame up here, and make sure when we shoulder partner we use that sentence frame. But I'll give you a couple of minutes to find the sum or difference for all 5 of those. All right, compare these 5 with your shoulder partner. The 1s take the odds, the 2s take the evens. Please use the supplied sentence frame for each of these. Go. When I call on you, please use the supplied sentence frame. Typically when we do this, I just pick a row. I don't think I've chosen this row yet, so go. Number 1.
I concluded that the sum is negative 13.1.
Very good. I'm glad you used sum. This is an addition problem. There are 13.1 negatives and 0 positives, and that's the reason why it's negative 13.1. We have 13.1 more negatives than positives. Number 2.
I concluded that the sum is 5.3.
5.3. We have 11.1 positives. We have only 5.8 negatives. We have more positives than more negatives. That's the reason why it's positive. And in fact, we have 5.3 more positives than negatives. Keep going here. Number 3.
I concluded that the difference is negative 0.4.
Negative 0.4. We have 5.3 negatives. This is a subtraction problem. We've tried to work on this idea of adding the opposite. Turn every subtraction problem into an addition problem. So we have 5.3 negatives and only 4.9 positives. We have 0.4 more negatives than positives, and that is one reason why the difference is negative 0.4. Number 4.
I concluded the difference is 16.5.
Good. And once we add the opposite here, all we have are positive numbers. We have 1.7 positives and 14.8 more. We have 16.5 positives and 0 negatives. One reason why the difference is 16.5 is because we have 16.5 more positives than negatives. And number 5.
Negative 17.4.
Sum or difference? Well, the way that it's written, that's difference, right? Now, if you added the opposite, and that's what you're looking at, that's different. So once you add the opposite, we have 17.4 negatives. Let me do that really quickly. We have 17.4 negatives and 0 positives. We have 17.4 more negatives than positives, and that's one reason why the difference is negative 17.4. So now we're just going to extend on an idea that we talked about when we were dealing with integers or addition problems with more than 2 numbers, like this. And if we take a look at a problem like this, the first thing, in my opinion, that we should do is everywhere we see subtraction, let's go ahead and add the opposite so that we've turned this into a straight addition problem. Because once it's straight addition, and what I mean by straight addition is it's addition in between each pair of numbers, that means we can now use the commutative property. And the commutative property tells us that we can add numbers out of order or we can multiply numbers out of order. So I would gather at this point all of my negative numbers together. And when I do that, I have 19.2, I have 21.2 negatives. And that was by simply adding all my negative numbers together using the commutative property. Now, I don't have any positives to add with this, but now I've turned it into a very simple problem utilizing the commutative property. I have 21.2 negatives, 15.5 positives. It should be obvious to you that we have more negatives than we do positives. In fact, we have 5.7 more negatives. So the sum between those two numbers is negative 5.7. Okay? I would like all of you, using the same strategy, to try number 7. All right, let's compare what we have with our shoulder partner. This is an odd number. The ones will take it. Please use the supplied sentence frame up here. So in number 7, using the same strategy, I see subtraction right here, so I am going to go ahead and add the opposite. And at that point, you can either gather all your positives together or your negatives. I'll go ahead and gather my positives together. I have 1.79 positives and 2.8 positives. That's 4.59 positives. And then I'm going to gather my negative numbers together. I have 3.2 negatives and 10.09 more negatives. That is 13.29 negatives. It should be obvious to you that now that you are comparing them, you have more negatives than you do positives. And in fact, you have 8.7, oops, I didn't mean to write a negative again. You have 8.7 more negatives than positives. And the way to figure that out is 13.9 negatives. Take away from that the 4.59 positives. That's going to tell you how many more negatives you have than positives. Okay? All right, go ahead and do number 8 and number 9, and then we will go ahead and compare with our shoulder partner and then go through those two. If I'm doing a problem like number 8, the first thing I do is I add the opposite right there. That's the only place I see subtraction, because now, since we have straight addition, we can gather my negative numbers together, and then I can gather my positive numbers together and do some comparing there. So when we do that, we have 350.98 negatives and 421.34 positives. I have more positives than I do negatives. In fact, I have 70.36 more. So I determined that the sum is positive 70.36. Number 9, same idea. Let's see here. I see subtraction in a couple of spots here, and right there. And now I can gather my negatives together, gather my positives together. I have 56.72 negatives. 71.28 positives. I can see that I have more positives than I do negatives. In fact, I have 14.56 more. So I concluded that the sum is 14.56. So now, taking the same idea and extending on something we talked about when we were restricting it to integers, let's take a look at number 10. Number 10 says Jenna has $125.76 in her account. She deposits $45.90. And withdraws $80.02. Later, she returns to withdraw another $40.50 and deposits a check for $250. So remember, withdrawing is taking out or taking away. Depositing is inputting. So we would have a situation that would look like this in terms of rational numbers. And in this situation, I would gather my positives together, gather my negatives together, and figure out exactly how much she has left in her account. So I'm going to let you take that and finish it. And number 10, gathering all my positives together, I have 421.66 positives. Gathering my negatives together, I have 120.52 negatives. I have more positives than I do negatives. In fact, I have 301.14. So I believe that the sum is $301.14. Now go ahead and do number 11 all the way through. So we represent each situation with a specific rational number. Positive 84.09 plus 19.23 plus 29, those are all the deposits. And then he wrote checks. Remember, when you write a check, it's taking money out of your account. So plus negative 53.87 or minus 53.87, and then plus negative 38.99. Gather your positives together. Gather your negatives together. We have more positives than we do negatives. In fact, we have 39.46 more positives. So I determined that the overall change is $39.46. All right, so the last idea for today is, since our focus has been on adding and subtracting rational numbers, what if we have one kind of rational number and subtracting or adding another different kind of rational number? In this case, a mixed number with a decimal. What could we do? You could turn the decimal into a fraction, or in this case, a mixed number. What else could you do other than that? So in this case, turn the mixed number into a decimal. It doesn't matter which way that you do that. I'm going to do this both ways. So as mixed numbers, it would be 3 3/4. I went ahead and added the opposite, plus 2.5, because 2.5 is 2.5. Or you could turn the 3 3/4 into a decimal, which is obviously 3.75. So we'd have 3.75 plus 2.5. Now, I don't care whether you do it the mixed number way or the decimal way, because the fact is 6 1/4 is equivalent to 6.25. They represent the same numeric value. Okay? Any questions about number 12? All right, I want you to do number 13 and number 14. We will then compare with our shoulder partner, and then we are finished for today.